Okay, so in this part, from example 4 onwards, we are going to be changing the range. So how I know that the range will be changing? So you look at the angle. The angle right now is a 2x. So 2x will change the intervals, but it doesn't change the basic angle. Okay, so don't go and divide the basic angle by 2 or whatever. So I will still do a sine inverse, ignoring the negative to get my basic angle. And I still do my normal ASTC. So I still do my normal ASTC. Sine is negative in the third and fourth quadrant. And this is in the degree mode. So it should be 180 plus alpha and then 360 minus alpha. So I'm still in my third and fourth quadrant. So now the trick is in the third step. So if you look carefully, we are given this, based on what you are given, angle X has to be between 0 to 360. So you multiply by 2. So when you multiply by 2, that allows the range of 2x. That means, right, 2x is allowed to stretch from 0 degree to 720 degree. So what is the integration of 0 to 720? That means, right, this is one cycle. You actually go through one more cycle. So you actually go through one more cycle. So the effect of going through one more cycle is you actually pass the third and fourth quadrant twice. So you actually pass through the third and fourth quadrant twice. Okay, so for example, the first one, so the first third quadrant, the first time you come to the third quadrant, it will be like this. That's why it's 180 plus 40.5. But if you carry on one more round, you are going to visit the third quadrant one more time. So these two are the third quadrant. Okay, now the fourth quadrant is 360 minus alpha. So the first time you are here, it looks like this. So this is 360 minus alpha. So you go one more round. So that's why you add a 360. So you actually visited third quadrant twice, and you also visited the third quadrant, the fourth quadrant twice. So all the four angles are meant for x, 2x. That means 2x is the angle that travels through the third quadrant twice, the fourth quadrant twice. But eventually our aim is to find x. So from here, all the answers divide by 2. 360 minus 40.5 divide by 2. Then this one also divide by 2. So all the answers you're going to divide by 2. So 2x traveled through third quadrant through 2 times. 2x also visited fourth quadrant 2 times. That's why there are 4 answers for 2x. And because there are 4 answers for 2x, each of the angle you divide by 2. So eventually you will get 4 answers for x. And if you look carefully at the 4 answers, it is within 0 to 360. So the 4 answers for x will still fulfill the original angle requirement. So that is the idea where you are allowed to go more cycle. Okay, so in the next question, you will see 3x. So the angle is 3x. That doesn't change the basic angle. You still do an inverse to find the basic angle. So the basic angle is still acute angle. And you do your ASTC, cosine is positive in the first and fourth quadrant. So first quadrant will be alpha, 360 minus alpha. But this time around, if you look carefully, because it's 3x, right? 3x actually go through 3 rounds. So the implication of 3 rounds means first quadrant is visited 3 times. So take a look. First quadrant. And this is the second time we visit the first quadrant. And then this is the third time we visit the first quadrant. So the first quadrant is visited 3 times. So each time you add the 360 because that's a one cycle. So the fourth quadrant is also being visited 3 times. So this is the fourth quadrant, 360 minus alpha. You add the 360. Okay, then you add one more 360. That's how I get the 1080. So fourth quadrant is also visited 3 times. So you visit first quadrant 3 times, and you visit fourth quadrant 3 times. So 3x visited first quadrant 3 times, fourth quadrant 3 times. So all these are done by 3x. So because of this, there are 6 sets of answers for 3x. And each of the 6 answers, you got to divide by 3. So eventually, you actually got 6 answers for x. And you observe your x. It should be well within 0 to 360 degrees. So it should be well between 0 to 360 degrees eventually. So we're going to do the same thing, but this time around, we're going to go for radial mode in the next example. So in the next example, this is angle. The angle is 2x. It doesn't affect the basic angle. But you do it in radial mode because 0 is between, x is between 0 to 6.28 radian. You realize I like to write out the value. If I don't write out the value, actually, I don't know. I don't know how much is it. Okay, so I execute my basic angle in the radial mode. I do my ASTC. I realize it's first and third quadrant. So where is my first and third quadrant? So it's alpha, pi plus alpha. Okay, so 2x is allowed to, when you multiply by 2, you realize that 2x is allowed to go till 12.6 radian. So it's essentially 2 rounds. So 2x is going to visit the first quadrant twice. So you will add a 2 pi. So this is the first quadrant. So 2x visited the first quadrant 2 times. So each time you add, the equivalent of 360 is 2 pi. So you add a 2 pi. Then the third quadrant is also visited twice. Pi plus alpha is visited twice. So you add a pi. You add the 2 pi. That's how I get the 3 pi. So the second time you visit that same quadrant, you're going to add a full cycle. So 2x has 4 answers because it visited the first quadrant twice. It visited the third quadrant twice. So from the 4 answers, you're going to divide by 2. And then eventually you get your 4 answer for x. And if you look at the 4 answer for x, it shouldn't exceed 6.28. Okay, so we will see one more question that also limits your intervals. So the next one, It is also a radian question, but this time around our angle is 2/3 x. So does it change your basic angle? No. You still execute your basic angle. I think, okay, this answer was pasted wrongly. So this answer was pasted wrongly. Okay, so let me execute the first step. So the first step is cosine inverse 0.9. Let me get my calculator. Okay, do it in radian mode. Cosine inverse 0.9. Okay, you will get 0.451 radian. Okay, you can write more decimal place. I actually store in my memory of my calculator. Second step, you execute. Second step, cosine is positive. So cosine is positive. So that meant is first and fourth quadrant. And because this is in radian mode, so it's alpha 2 pi minus alpha. Okay, so the interval is 0 to 2 pi for x, but our angle is 2/3 x. So I'm going to multiply by 2/3. Zero multiplied by 2/3 is 0. So you just try to multiply by 2/3. So after you multiply by 2/3, you can punch the calculator. You punch your calculator, you realize that you are restricted to 4.1887 radian. So 2/3 x is allowed to go to 4.1887 radian. So let's try to get the answer. So 2/3 x is going to visit the first quadrant. First quadrant is 4.51. 2/3 x is also going to visit the fourth quadrant. So do we continue some more? So actually you got to check. You got to punch calculator to check. So punch this one on your calculator. So if you try to punch this on your calculator, you'll realize that this is 2 pi minus alpha. Okay, I think I punched wrongly my calculator. So you try to punch out 2 pi minus alpha, you'll realize that this is 5.832 radian. So if you punch it out, you realize that it exceeded the 4.1887 radian. So 2/3 x is only allowed to go as much as 4.188. So this one already exceeds. So what do? You can just reject it. That means by right, 2/3 x, I mean, as in like, the angle can be allowed to visit first and fourth quadrant, but it has insufficient. It is insufficient right now. So you're going to reject. So there's only one answer that is acceptable. So from here, you use the only answer and divide by 2/3. So you will get 0.677 radian. So in this question, you somehow don't get the 2 answers, don't get the 4 answers, because you're limited by the range. So you go through the same process every time. Make sure you max out the interval. So then you can see how many answers you have. So usually they will have questions that trick you on this. Okay, so that is the main 4 steps that you got to take note of.